again to the office hours. In this episode, we're going to be doing another lesson on NetworkLessons.com, and this one will be on Ospf packets and neighbor discovery. So in this lesson, he's going to show us the different packets Ospf uses and how neighbor discovery works. Ospf uses its own protocol like EIGRP and doesn't use a transparent protocol like TCP or UDP. If you would look at the IP packet in Wireshark, you can see that Ospf has protocol ID 89 for all its packets. Looks like you can maybe verify with that with this command. If you do a debug IP Ospf packet, anyway, no, you can't. You're not going to see protocol ID 89 here. So if we use debug IP Ospf packet, we can look at the Ospf packet on our router. Let's look at the different fields we have. V2, what does this stand for? It stands for Ospf version 2. And if you're running IPv6, you'll be running on version 3. And we have T1, stands for Ospf packet number 1, with which is the hello packet. Then we have L48. This is the length of the packet in bytes. The hello packet appears to be 48 bytes long. Then we have router 1's router ID, which is 1.1.1.1. That's being received on R2. Then we have AID, which is the area ID in dotted decimal. You can write the area in decimal, area 0, or dotted decimal, area 0.0.0.0. We have a checksum to see if this packet is corrupt or not. And we have a AUT0, which is the authentication type. And it looks like it's not using any authentication. And we have the source, which is fast Ethernet, 0/0. Let's move on. So it looks like there are 5 different Ospf packet types. Let's go over them. So first we have the hello packet, which is for neighbor discovery, and we use this to build neighbor adjacencies and to maintain them. Next we have a database description. This packet is used to check if the link state database between 2 routers is the same. The DBD is a summary of the LSDB. We then have a LSR, a link state request packet, which requests specific link state records from an Ospf neighbor. We have a LSU, a link state update, which sends specific link state records that were requested. This packet is like an envelope with multiple LSAs in it. Then we have a LS acknowledgement. Ospf is a reliable protocol, so we have a packet to acknowledge to the other neighbors. Ospf has to get through 7 states in order to become neighbors. They are down. If you're in down state, no Ospf neighbors detected at the moment. And then we go to init state, which says that a hello packet has been received. Then we'll get to two-way, and means own router ID found in received hello packet. And we have xstart, master and slave rules have been determined. Then exchange, database description packets are sent. Next we'll have loading, which means we'll exchange LSRs and LSU packets. And finally, we'll have full, which means Ospf routers now have an adjacency. let's take a detailed look at this process. So there's no lab in here. Oh crap, I forgot to turn my Slack to the side. Sorry, Brett. Anyway, there's no topology or I think configurations to follow. So this one we're not going to use GNS34. So we have R1 and R2 connected via a single link, and R2 seems to have a loopback interface that is probably going to be advertised to R1. This is a topology that he's using. R1 and R2 are connected using a single link, and we'll see how R1 learns about the 2.2.2/24 network. So R1, I suppose they're both in downstate right now. R1 is going to send a hello packet. As soon as I configure Ospf on R1, it will start sending hello packets. R1 has no clue about other Ospf routers at the moment, so it's in the downstate. The hello packet will be sent to the multicast address of 224.0.0.5. R2 receives the hello packet and will put an entry for R1 in its Ospf table. We are now in init state. Neighbor table router R1, okay? And R2 has to respond to R1 with a hello packet. This packet is not sent using multicast, but with a unicast. And in the neighbor field, it will include all Ospf neighbors that R2 has. R1 will see its own name in the neighbor field in this hello packet. R1 will receive this hello packet and see its own router ID. We are now in a two-way state, and two-way is the third state. I have to take a pause here. If the link we are using is a multi-access network, Ospf has to elect a DR and a BDR. This has to happen before we can continue with the rest of the process. In another lesson, I'm going to teach you about DR and BDR. But for now, just hold that thought and just realize that a DR or BDR election happens right after the two-way state. Our next stop is the Xstart state. Our routers are ready to sync their LSDBs. At this step, we have to select a master and a slave role. Let's see. R2 sends, I will start, but R1 says, no you won't. The router with the highest router ID will become the master. R2 has the highest router ID, and it will become the master. In exchange state, our routers are sending a DBD. What does DBD stand for again? DBD, database description. And in Xstart state, database description packets are sent. Coming back down here. So the routers are exchanging DBDs with a summary of the link state database. This way, the router can find out what networks they don't know about. When our routers receive the DBD from the other side, they will do a couple things. They'll send an acknowledgement with an LSAC. They will compare the information on or in the DBD with the information it already has. If the neighbor has new or newer information, it will send a LSR packet to request for this information. When the routers start sending LSRs, we are in loading state. The other router will respond with an LSU with the requested information. So that's here, where R1 is asking R2 to send him more information about the 2.2.2/24 network, and R2 sends an LS update that tells him about the 2.2.2/24 update, and R1 sends an LS ACK. When R1 requested information about 2.2.2/24, it used an LSR. R2 will send an LSU with the requested information. R1 will send an acknowledgement with the LSAC packet to finish. We are now in the full state. Both routers have a synchronized LSDB, and we're ready to route. All right, so I highlighted some fields. You can see the two-way communication, the struggle for power to determine who is the master and who's the slave, the exchange of LSDB summaries using another DVD packet, and finally an LSQ and LSU. What is an LSQ? Does he mean LSR? And I suppose that's it for this lesson. Thank you for watching. There was no lab here, so another quick one. I'll start up another session for the next lesson, which will be on the DR and BDR election. Thanks for watching.